As nice as it is to talk about vulnerable code, it's also nice to figure out how to fix that code. So let's take a look at this example here. On the left-hand side, we see a program, again, written in C. And what it does, starting here in line 22, where the main function begins to execute, it's just going to briefly print the name of the program so that we know how we invoked it. And then it's going to test to make sure that we have enough command line arguments. In this particular case, our command line argument, we have to provide 1 in addition to the command itself. Has to be a name that we're going to print. If we don't have that name, we're returning -1 as a return code. And otherwise we're going to return whatever the full function returns. And the full function is called the first command line argument. So the first element of the argv array over here. I should say argument number 1, not the first one. Argument 0 is the entire command invocation. Then coming into the function here, in line 6, we define the function parameters. In other words, foo is going to return an int, and it's going to take a pointer to a character or a character array as its input. This is a common way in C to pass strings. We're going to define 3 variables even on the stack. One is a string, a character array of buff size characters, and buff size is defined as 80. A second array, which is the exact same size, so they can hold the exact same amount of data, and just a counter. At that point, we're going to copy into the string buffer our name, the name that was given in as a command line argument. And we're going to use that to build out the reverse array. And how are we doing that? We're a simple loop which starts at the back of the string length -1. Remember, the first character in the string is 0, so if I have a character of, say, a string of 10 characters, it is indexes 0 through 9, so -1. Each time that we're going to go through this loop, we're going to decrease j by 1, and we're going to continue as long as our j is greater than or equal to 0. At that point, reverse j, which is the first time around, the last character in the reverse string will be the first character of the first string, and so they flip each other around. And then we're just going to print our values and return 0, which then immediately passes through here to return 0 for the end of the program. And remember, C programs return 0 when everything is fine, in other words, when there are no errors. So let's go make sure that we have the latest version of this executable here. Make a buff fix. It's already up to date, so I can just run this. And it's telling me exactly you must add the name as a parameter. That's what we expected. So I can just add my name. And as we expected, the program works. It's telling me your name is this. In reverse, that's that. Now the question is this program vulnerable to buffer overflow? Because I don't have any getS functions in here like we had before. Buffer overflows can happen anytime that you're taking user input. And in this case, the user input that we are providing is this command line argument. It's not read in through getS. It's passed into the program itself here in this character array of argv, but it's input nevertheless. And so as soon as we start manipulating this string, and especially if we try to map this string, which is potentially very long, here into a string that is defined as at most 80 positions long, this is where our buffer overflow root vulnerability sits. So root vulnerability of this buffer overflow vulnerability is below. And that's where it is, here. And why is that? Because I am taking a potentially limitless string and I'm copying that in a limited buffer, the buffer of at most 80 characters. And that's where we're going wrong. So let's see if we can make that work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So I have 10 characters here. 10 characters, fine, the other way around. 20, 30, 40, 50, 60, 70, 80 characters. Now we break. And why is that? Well, it's because in C we have these null terminated strings. So this is not a string of 80 characters I'm passing in. This is a string of 81 characters. Let me take the last one off. And that one still works. So we see exactly that if we go up to the maximum size that this array can hold, which is 79 characters plus the null characters, it works. As soon as I add one more character, and in that case I am copying more data into this string buffer than it can hold, it's going to break on me. And that's something we want to fix. So question is, how do we fix it? Well, the answer is pretty straightforward. Don't copy more data into a buffer than it can hold. If the whole vulnerability is you're copying more data than it can hold, then not doing that fixes the vulnerability. And the easiest way to do that is using, and let me pull up the manual page so you can see what it's like, a function called strncopy. strcopy is what I'm using. strncopy is what I should be using. And so if we look at the function prototype here for strncopy, we see that it's the same before. So the first argument to the function is a destination. The second one is the source. That's exactly the same thing as over here. But the third one is the length of my string, of my buffer, I should say, the largest amount of data that I want to copy in there. And so that's that. And by doing this, saving this, I've now fixed my issue. Let me double demonstrate it to you. I've recompiled my program. It still works the way it should be. But when I start, this is my 79 character input. This is my 80 character input. And that now works. It no longer crashes. Even if I double this input, it's still working without issue, except it stops after having read 80 characters. 79 plus a null. And just by changing this function to strncopy, I have fixed my buffer overflow vulnerability. Let's take a look back at the first program that we inspected, which just printed hello world and then called the function foo, which then read a buffer of characters, but did not check the size of the buffer. Now, good practice is to define these sizes as preprocessed symbols, so I don't have to repeat them, and I can change them in one location. So here is where the root cause vulnerability is. Vuln is here. We want to fix that, and just like we had the string copy and the strn copy, instead of getS, we want to use fgetS. And why is that? Because in the fgetS function, we can also restrict how many bytes to read. So this function really becomes nothing more than what? Well, we're going to read into buff, no more than buff size characters, and we're going to read that from standard input. This can go commented out. Let's save my program. I'm going to compile it. Buffer Overflow. And when I run it, not only does the compiler now not yell at me anymore for using an unsafe function, it still works. 4, 5, 6, 7, 8, 9, 10 characters, but let's add a couple more. 20, 30, 40, 50, 60, 70, 80. It still does not crash because I'm only reading the first 50 characters and everything else I'm ignoring. So again, the same fix as in the previous program. The only thing I did was limit how many characters I'm willing to read, and that prevents my buffer overflow in this example.